So we have seen that information plays a big role in our assessment of probabilities, and in fact every probability value that we can come up with is always based on some information, and therefore the two important points we saw was that if the information changes, so does the probability. Not always, but so does the probability usually, and that we have to pay attention to the information on which the probability that we see was based. Now, couple of consequences about this is that we're going to be talking about probabilities being estimated, not computed. So we're always going to be dealing with probabilities as something which provide us some information, some knowledge, but not definitive knowledge, not conclusive knowledge. And that is because, first of all, not all the information about an event is always available. In fact, most of the times we know very little about the event. There is in fact a train of thought that says that the only reason we need probabilities is because we don't have full information about an event. And if we knew everything about the event, then we would know exactly if it's going to happen or not. We wouldn't need probabilities. There's another train of thought, that actually another philosophy that says, well, no, that's the issue of probabilities is inherent in our world, but we're not going to go into philosophy, right? The other reason why we're going to estimate these probabilities is that even if we do have substantial information, some of that information may not be totally correct. I'm not talking about lies or anything like this, but sometimes the information we may have may be slightly inaccurate or incomplete or something like this. Because of this, we're going to be always talking about estimating probabilities and not computing. Well, there is a little exception. You'll see in a minute, but pretty much that is the idea. Now, there are three main methods to estimate probabilities, and you probably have seen all three methods in action, but probably have not seen them described in this way or classified in this way. The first one is a method which is called the logical. It also has another name, which I will introduce in a second, and it's pretty much based on just using logic, thinking about the event and thinking about what can possibly happen and how and so on. The second one is called empirical. This also has a different name, which I'll show you in a few minutes. And empirical just means that we're going to estimate our probability based on observations, based on fact, based on what we've seen in reality, independently of how we think through the event or about the event. The third one may be a little bit surprising for you, because the third one is called subjective, and here I don't mean that your opinion is as good as mine, but I mean something where again individual people's opinions about an event are at the base on which we build our estimate of the probability. But again, I'll say a little bit more about this later on, so don't make up wrong ideas about it. Let's have a look at these methods one at a time. So the logical method is also called the classical method because it's one of the first methods that was developed, and it's the one that is usually presented first when we talk about probabilities. And it uses assumptions and logic to compute a probability value. Now, I just said that we're not going to compute probability values, we're going to estimate them. But in this case, we can talk about computing a probability value, even though what we come up with is still an estimate. The reason is that in this situation, what we do is we're going to start from certain assumptions. We're going to assume that certain things are true, and then based on those assumptions, we're going to think logically about the event, and we're going to compute on the basis of the assumption and the logic what a probability should be. The end result is still an estimate, but we arrive at it through some computation. For instance, this is the stereotypical, the traditional example. Let's say I have a coin and I flip it. What's the probability of getting heads? Well, what we're going to do is we're going to make some assumptions and we're going to think through it. What are the assumptions? The assumptions are that our coin has two sides, and those two sides are equally likely to happen. Okay, so it has tails and heads, and once we flip it, we don't know which one is going to occur, but we assume that both sides are equally likely to occur. Now, this is a reasonable assumption, although a coin usually has one picture on one side, one or different on the other side, and therefore it's possible that one of the sides is slightly more likely than the other one. However, if we assume that they are equally likely, the way we think logically is this way. Our certainty has a probability of 1. This probability of 1 is going to be split among two events which are equally likely. Therefore, each one of them is going to have a probability of 1/2. And that's the logical approach, or the classical approach. It gets way more complicated than that, and you may remember maybe from high school some complicated calculations about probabilities. We're not going to get into that, but this is the idea. We can also apply this kind of thinking and approach to biological situations. For instance, we can think about trying to predict the sex of a newborn by using logic and making assumptions. Okay, we know that sperm cells come in two varieties, male and female, and that these are generated by cells that actually have both the X and the Y chromosome, and then they split. One of them becomes an X chromosome sperm cell, the other one becomes a Y chromosome sperm cell, and therefore we can assume that sperm cells are present in equal quantities, males and females, and therefore that the probability that one of them will fertilize the egg is 1 in 2, so it's 1/2. So once again, to have two types of sperm cells which are produced in equal numbers, notice that's an assumption. We're also assuming that they are equally likely to fertilize the egg. If all that is true, then we're going to compute that our probability of 1 of certainty is going to once again be split into two equal probabilities. But you can see how these assumptions may or may not be true, and we may not know enough to be sure that they are in fact true. So let's look at the, I see that the heading there has changed. That's okay. I hope you don't mind that. The second method, I was just distracted for a second there. The second method is called empirical, or also frequency method. And it is because, again, it uses collected data and a formula relying on frequency. The formula is this one. So what we're going to do is we're going to run a number of observations. We're going to see how many times the event occurs, and then we're going to compute the ratio of the number of occurrences divided by the number of observations. And we're going to use that as our estimate of the probability. Notice that this is very much like the law of large numbers. It tells us that the probability is pretty much the proportion of times that the event will occur. So we're just going to run the experiment and see how many times that happens. So as far as examples are concerned, when we're using the coin flipping situation, what we're going to do is, instead of thinking logically about the whole thing, we're going to say, oh, forget about logic, just flip the coin, do it many times, and see how many times we get heads. And then the ratio of times that we got heads out of the total number of times that we flip the coin will be our estimate of the probability. In the case of the sex of a newborn, all we can do is basically just observe a large number of births and find out how many of them are boys, how many of them are girls, and that will tell us the probability that a child will be a boy or a girl. Okay, so it's just based on facts. We're not thinking, we're not making any assumptions, we're just seeing what happens. The last method for computing probabilities or estimating probabilities is called the subjective method. And again, just let's be careful about this one. It's not subjective in the sense that my opinion is as good as yours, but it's subjective in the sense that it uses the general and relevant knowledge of experts, subjects, people, okay? But people who have to be experts. Okay? So how about our examples? Well, in our examples, for instance, if we want to know the probability of getting heads when flipping a coin or any other thing related to games of chance, what we might do is we might ask a casino dealer, right? Or someone who does that for a job, or maybe a referee in a sports game where they flip coins all the time to decide who starts first. So we're basically asking an expert to find out, in your opinion, in your expert opinion, what's going to happen here. In cases of sex of a newborn, we might do the same thing and maybe ask a group of gynecologists or similar specialists, again, to base that not so much on the logic of the sperm cells that I used earlier, but just on their general knowledge, what they know about what happens in the process of fertilization and so on and so on. So that might tell us that in fact there is a slightly higher probability of having a girl than a boy based on a number of reasons they might have. So again, we're not asking just the man in the street, but we're asking some experts to come up with a good opinion about it. So how are these methods used in health research? The logical method is not really used much directly, as you can tell. I mean, in most health situations, we don't really have a lot of reliable assumptions that we can use, and there's not a lot of logic that we can follow from those assumptions. So there's not much we can do about that. But it is used indirectly, as we're going to see in the second term, in clinical trials, in setting up clinical trials, or in the reasoning behind statistical tests, which is going to be the main topic of our second term. The empirical method, well, this is used all the time. Okay, every quantitative health research is based on data collection and analysis, and therefore, as such, is based on the empirical method. Remember, empirical means based on fact. Okay, the subjective method also is used quite a bit. For instance, okay, but it's used a little bit more underground, right? For instance, how do I pick which experiment to do? If I want to run a clinical trial, how do I choose which procedure I think is going to work? Well, that's going to be given by on the basis of the recommendations made by experts. The experts will tell us, look, there is a good chance that this procedure is going to work, and therefore you might, if you have to do an experiment, you might as well do it on the basis of this particular procedure or treatment and so on. So it's a little bit of an indirect way of doing it, but it is a method that, again, it is used, and you want to be aware of that. So this is it. So we'll see in class how all these basic ideas are implemented in a number of situations, both related to your data, to the articles we have seen, and maybe some other applications that we're going to come up with.